All right, hello everyone. So we didn't quite have time in class for this, but you might need this on the homework. And so I wanted to just do a quick summary of what absolute value is. And it's something, of course, you've seen before. We all know what absolute value should mean, right? That, like, let's just do an example here. The absolute value of -4, we want to think of that as just being +4. And so what absolute value does is it just removes the sign if it's negative and doesn't do anything otherwise. And so I've written that out here in just a little bit more detail. So if we have an ordered field, the absolute value of an element, well, if that element is positive or 0, then we just take that element. So the absolute value of 5 is just going to be 5. And if that number happened to be negative, then we're going to negate it, right? So the absolute value of -5 is going to be -5 with a negative in front of it, right? Which of course is equal to 5. So the main thing I want you to know about absolute value, the main thing that I think is going to be so useful in this class, is how to think about inequalities involving absolute value. So if I say the absolute value of something is less than 5, and there's a reason I'm putting a smiley face in there, because I don't want you to think about it as an x. I don't want you to think about anything. I want you to think about it as a something. If I tell you that the absolute value of this smiley face is smaller than 5, I want you to think about where that could be. Could that smiley face be 0? Is the absolute value of 0 less than 5? Yeah, it is. Is the absolute value of -3 less than 5? Yeah, the absolute value of that would be 3. Right? What about 4.9? Is the absolute value of 4.9 less than 5? Totally. And so where could this smiley face be? Well, I guess it can't be bigger than 5. If I put it out there, its absolute value won't be smaller than 5. And I can't put it out here, right? If it were -6, then the absolute value would be 6, and that's not smaller than 5. And so where can I put this smiley face? It means that that smiley face has to be between 5 and -5. Right? So I know that seems like a super obvious thing, like when you draw the number line and you kind of think through it, but this is so important, right? So let me just do another example, right? This time without the smiley face. If I want to know what it means for the absolute value of x minus 4 to be less than 1, well, what did that mean? That's equivalent to, I'll even draw equivalent to, saying that that smiley face has to be between 1 and -1, right? Whatever that smiley face in here is, it's got to be between 1 and -1, right? And of course there's no smiley face here. Our smiley face is x minus 4. But notice it's not x. What I put in the middle was exactly the same as the argument of the absolute value function. Okay? And then of course I could simplify this. And I could simplify that, and that means x is between 5 and 3. And yeah, and I get a better description of that. Right? So this is going to be so important. I can't emphasize how much that's going to be useful. Okay. So now I just want to prove a triangle inequality, and I think this is the last thing I'll do in this video. And so anytime we have an ordered field, and for us, typically we're going to have two numbers that are real numbers, then it's going to be true that if I take the absolute value of x plus y, that's going to be less than or equal to adding the absolute values up separately. Okay, so let's prove that. Okay. And how will I prove that? I will prove that the smiley face, right? I want to show that this is saying the absolute value of smiley face is less than some number, right? This statement, I know it looks a little different, is saying the absolute value of something is smaller than something else. And so I'm going to show that that smiley face is between the star and negative star. Okay? Now I'm gonna erase the smiley face. I'm gonna erase the stars, because we need to understand what's going on with the actual quantities. So what I'm going to show is I'm going to show that that argument of the absolute value function is between our star and the negative of that star. Right. I have got another video on the YouTube channel where I kind of talk about that the smiley face thing, if you want a little bit more detail on that. But basically, we're always going to, when we see an inequality like this, absolute value of something is less than something else, I want us to think about it as saying that this thing that we're taking absolute value of has got to be between that quantity and its negative. Good. Right, and so I say I will prove that. And so now let's do it. So let's do it. All right, a little bit of encouragement never hurt a proof. And so let's see. So let's see what we know. Well, we know that absolute value of x is either equal to x or negative x. Okay, maybe I'll kind of write that like that. So the absolute value of x, so it's either itself or it's the opposite. And I know the same thing about absolute value of y. Right? It's either equal to y or negative y. Okay. And so I'm just going to kind of turn this on its head, and I'm going to say, well, whatever x is, it's definitely got to be between the absolute value and the negative absolute value. Right? After all, one of these two things is equal to x. Right? X is either going to equal its absolute value or vice versa. And I know that y has got to be between the absolute value of y and the negative absolute value of y. Okay. In fact, I don't even know that this reason up here is so helpful. Right? The idea is that I know, kind of by definition, that any number, well, it's literally equal to either the absolute value or its negative. And so I know that these two statements are true. And so now we will build a chain of inequalities to achieve our goal. And so I'll write goal up here to remind us where we're going. And what I'm going to do is I'm just going to start with the lowest thing, so negative this. So what I ultimately want to show that this quantity is smaller than x plus y. So let's see what it's equal to. It's negative x plus negative y. And I can look at that and I can say, well, you know, negative absolute value of x is smaller than x. Okay? So using that red fact there is going to be, this is going to be smaller than x plus negative absolute value of y. Okay? One way you can think about it, if you really want to go back to the axioms, is what we did was we took this red inequality here and we added negative y to both sides. Right? I don't think we need to go into that level of detail there. I think it's reasonable for the reader to look at this and say, oh, I see you've changed one thing, negative absolute value of x for an x, and that's followed by the highlighted portion. And now we can do the same thing up here. Now let's do another example. So I look at this and I say, well, x plus the negative of the absolute value of y, well, that's going to be less than x plus y for the same reason up here. So I'm choosing to label my inequality usage by highlighting things. You might want to, maybe you might want to label these by, you could call this 1, we could call this 2. And you might want to write something like by 1, by 2. Right? And now look at what we've done. Already we've shown that half of the inequality is true. Right? We've already shown that the negative of this thing is less than or equal to the middle thing. All right, let's keep going. So now what do we want to show? We now want to finish the rest of it. We want to show in our goal that x plus y is less than the absolute value of x plus the absolute value of y. And so now I can just keep going, right? So I use kind of the same thing. Maybe I'll choose a different color now, maybe purple. Right? I also see this inequality here and this inequality here. So I know that x is less than or equal to absolute value of x. Y is less than or equal to absolute value of y. And so I could do by 1 and 2 again. If I want to color code that, I can use that. And so I have shown, put a period here, I have shown that negative absolute value of x plus absolute value of y is less than x plus y, which is less than absolute value of x plus absolute value of y. Okay. All right, and that, again, is following from this long chain of inequalities here. So this whole thing is kind of building to that. And that's it, which was my goal. So maybe just one more thing just to show you some examples. Let me just scroll down to the bottom of this. Just one kind of cool example of the triangle inequality is, remember, it applies to everything. So if I have something like this, if I have something like x minus something like x plus y minus 9, I could take that and I could rewrite that. I could do anything in the world as long as they're equal. I could write this as x plus 10 plus y minus 19, right? It's a free country. These are equal, right? They're both equal to x plus y minus 9 absolute value. And then what I could do is I could think of my triangle inequality, which says the absolute value of thing plus other thing is less than or equal to absolute values of the things added. And so here I see thing 1 and thing 2. So this is going to be less than or equal to the absolute value of x plus 10 plus the absolute value of x minus 19. Oh, sorry, of y minus 19. Okay. So one thing we're going to have to do in this course sometimes is we'll have to be clever and notice how to split up these inequalities in ways that help us. So thank you for watching. And